Rational root and other theorems. In this unit, or in this lesson, you're going to learn how to factor a polynomial of degree greater than 2 and write a polynomial expression in standard form from the zeros. Same thing you've done before. Now, theorems about roots and polynomials. There's a good bit of these notes that I've given you that are just review, that have some examples that go back over things that you've already done. Okay? Quick review with regards to solving polynomial equations of higher order. Solve the polynomial, find the roots, find the zeros, factor the polynomial, and express the roots. Those are all different ways of saying the same thing. Now, when you're given a polynomial, how many roots should you expect to find? Well, a polynomial of degree n will have n roots, some of which may be multiple roots. They repeat. For example, a polynomial of degree 3, highest power, will have 3 roots. We will now look at what you already know and then add to your cache of tools for solving polynomial equations. Here, this first one, x to the 4th equals 13x squared minus 36. Okay, solution. Recognize a pattern within the problem. It's not a quadratic, but it's in quadratic form. First off, we're looking for 4 roots because it's a 4th degree equation. Then we set the equation equal to 0, and we notice that this problem is really the variable x squared being squared and being used to a power of 1. Get in the habit of looking for this pattern. It happens a lot. So if we let a equal x squared, then we can rewrite it. Then it's easy to factor. Once we factor it, we can replace the a with x squared, and we find that our answers are plus or minus 3 and plus or minus 2. Again, if you need to, you can come back, pause the video and look at this, or just read through your notes. The second thing, well, find a common factor. That's the first key. Now notice that we're looking for 5 roots because it's a 5th degree equation. And we don't know how to solve a 5th degree. But what we can do is we can take out a t. We'll take out a t. Now we've got a t to the 4th, a t squared, and no t. Oh, we're back to an example like number 1. So we've got t squared squared and t squared. We can factor that. And again, notice here, the t all by itself gives me t equals 0. The t squared winds up being plus or minus square root of 7, and the t squared minus 3 winds up being plus or minus root 3. Here we have 5. We've got 1, 2, and 2 more, or 5 solutions. So far, fairly easy, right? Now, okay, finding the zeros of polynomial, solution method, use the quadratic formula. Now notice here, I've got it already factored, and the linear factor is easy. I set that equal to 0. Boom. That's right down here. But this guy, if I'm looking for factors of -7 that add up to +5, well, they don't exist. -7 is either 7 and -1 or -7 and 1, neither of which works. So it's not factorable. Therefore, I use the quadratic formula. Okay? Now, factoring is just easy. It's faster if something does factor. But again, I'm expecting 3 solutions. Why 3? X squared times the x would give me an x cubed. So my degree is 3, so I'm looking for 3 solutions. There's 2 here and 1 here. Plus or minus, that gives me 2. Now, all that was great, since there were ways to get started. But what about the following? Now, I'm going to start with something very easy. And yes, we could factor this by grouping. But let's say we didn't know to group, okay? I want to teach you about the rational root theorem and how to use it. So we're going to start with some very easy things that have got nice, easy solutions. So don't look too far ahead. Pretend like you don't recognize grouping here. This polynomial could be factored, but what if we were not sure where to begin? Where do we start? And it's not an x to the 4th. It's not in quadratic form, and it doesn't have a greatest common factor. Well, you're going to start with the q-tip and the rational root theorem. Q-tip. And then here, this is the rational root theorem in math speak. Read it. Ooh, mumbo jumbo. What does it mean? Well, let's see. I use a Q-tip so you remember Q is the lead coefficient. P is the constant. That's why the Q-tip, so you can keep track of which one comes first. Because in the alphabet, P comes first. Now, a degree is 3, so there are 3 roots. Roots may be rational, irrational, or imaginary. Irrational and imaginary roots always come in pairs, so there must be at least one rational root. Now, the way we use the rational root theorem, the lead coefficient is Q. All the factors of 1 are plus or minus 1. The constant is negative 3. All the factors of negative 3 are plus or minus 1 and plus or minus 3. You just list them individually, and they'll all be plus or minus. Now, all possible values of P divided by Q are the possible rational roots. Remember, rational is simply a number that can be written as a fraction using integers. Okay? An integer numerator and an integer denominator. So here, P over Q, I take the P over the Q, I get 1 over 1 or 3 over 1, so I've got plus or minus 1, plus or minus 3. Now, one of these must be a root. So, how do I figure it out? Well, this is where the synthetic division comes in. Take a look at this. I've got 1, 1, negative 3, negative 3. You've got your paper so you can see all of it, but it's 1, 1, negative 3 are the coefficients. So, what I'm going to do is I'm going to start trying. I try 1. There's a remainder. So, no. This tells me that x minus 1 is not a factor. This one tells me that x minus 3, not a factor. This one, ooh, yay, this says that x minus negative 1 or x plus 1 is a factor. And over here, this tells me that x plus 3 is a big no. Okay? If the remainder is 0, then I've got a factor. Now, how in the world does that help? Well, notice you've done a couple of things. By using synthetic division, not only do I have a remainder of 1, and I know that x plus 1 is a factor, I also know if this was x cubed, this is the coefficient for x squared, this is the coefficient for x, and this is the 1s. So now I know that I have x plus 1, and then I have x squared plus 0 x's, so I don't write that in, minus 3. So this is how I know these guys. Now I can solve each one of these, and actually I don't need the quadratic formula. Over here, I subtract 1 from both sides, and x is equal to negative 1. Over here, I'm going to add 3 to both sides and then take the square root. I have 1 rational and 2 irrational roots, which make a total of 3 roots for this equation. These are my roots. Okay? Now, there are 3 problems here. If you would like, if you think you know it, or if you're watching this video as a review or a reminder, try these 3. If you're watching it for the first time, you might want to watch one and then pause the video and try it, that kind of thing. Do what you need to get the practice that you need. Now, usually when I'm listing these out, by the way, I put factors of P and then I list the factors of Q. This way I already have P over Q. Q-tip. Here, I've got 2x cubed minus x squared plus 2x minus 1. The number of roots is 3. The factors of P. Here's P, plus or minus 1. The factors of Q, plus or minus 1, plus or minus 2. Possible rational roots. Now sometimes too, I'm going to ask you just for the possible ones. I'm not going to ask you to solve it. Just tell me the possible ones. Well, 1 over 1 is plus or minus 1. 1 over 2 is plus or minus 1/2. Now, to finish it up, I've got to try some of these. And realize that I'm going to show you something that you can do that won't just be pure trial and error later. But right now it's trial and error when you've got a small number of rational roots. So, I look at this and I say, okay, what if I try 1? I bring 2 down. I get 2. I get positive 1. I get 1. I get 3. I can stop right there because I can see that I'm not going to wind up with 0. So I start over and I say, okay, I know it can't be 1. Well, what about 1/2? I bring down the 2. 1/2 times 2 is 1. I get 0. 1/2 times 0 is 0. I bring down the 2. 1/2 of 2 is 1. I get 0. Ah, happy face. Happy, happy, happy face. This tells me that I have x minus 1/2, and then I have 2x squared plus 2, and it all equals 0. Now here, if all I'm doing is solving, I can say that x is equal to 1/2. If I'm looking for the factors, I want to rewrite this as 2x minus 1. And then this is 2x squared plus 2, or you could factor out the 2. Now, x is equal to 1/2 over here. 2x squared is equal to negative 2. X squared is equal to negative 1. X is equal to plus or minus I. 1, 2, 3 solutions. Solutions can be imaginary. Let's try the green one. Again, now, if you think you know what you're doing, great. Pause the video and check it out. If you're not pausing the video, the number of roots equals the degree, which is 3. The factors of p, well, that's plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. You typically write them in numerical order. The factors of q, plus or minus 1. So the possible rational roots, every p over every q, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Ooh, that's a lot. That could be a long time of guessing and checking. So what if you've got a lot of them? Well, then you can take your calculator, and one of the things that this does, it says, I'm going to cross, if there's a rational root, it's going to be between negative 10 and positive 10. This is my biggest possibility. So I turn my calculator on, I hit y equals, and I clear this out. Now, I've got, oops, got to go back up here so I can see the equation. Sorry about that. And I'm going to have x cubed minus 2x squared minus 5x plus 10. I hit enter. Now I can go to my window, and I want to make sure that my x min and my x max incorporate the largest possible rational root. Whoops, down here. So since it's negative 10 to positive 10, I might change this to negative 12 and then to 12, just so that if it actually crosses at 10 or negative 10, I can see it. And I really don't care about the height. So now I'm going to graph. Okay, now I can see it's somewhere in between here, and it looks like it could be negative 2 or 2. Huh. All right, well, if it's negative 2, then I should put a 2, oops, I should put a negative 2 in the seat. So I'll put negative 2. I bring the 1 down, I get negative 2, I get negative 4, I get 8. This gives me 3, and this gives me negative 6. I've got 4. Well, that's not it. But it looks like it, doesn't it? Well, what if we do a zoom box? I'm going to do a zoom box. I want to zoom in a little bit. So I'm going to go out here, go down a little bit. I'm going to hit enter. I'm going to come over here. I'm going to go up. And I'm going to hit enter again. Ooh, notice it's not actually on -2, but this one does look like it's on +2. Huh, that's just barely off. Well, that's interesting. Let's go back now and let's try +2 and see what happens. I bring down the 1, I get 2, I get 0, I get 0, I get -5, I get -10. Ooh, that one worked. So 2 works. That means that I have x minus 2, that comes from this guy, and then this is going to be x squared minus 5 is equal to 0. X is equal to 2, okay? And then we have x squared is equal to 5, so x is equal to plus or minus the square root of 5. Ah, the square root of 5 is awfully close to 2. So if we go back and we just investigate a little bit more, notice it looks like it's crossing at 2 and then again over here. If I want to really zoom in and see this, okay, I can come over here and I can hit enter. I can go below, go across, and I just want to see what's going on here. Ah, see, it crosses at 2 and then it comes back up a little after 2. That's that positive root 5, just like a little beyond -2 is negative root 5, and then it's 2. Now, using the calculator to zero in on a possible rational root, the first one we checked was wrong. The second one we checked was right. But when we looked at the graph overall, we could very quickly and definitely cross out all of these guys. The only possible ones from the graph were plus or minus 2. So the graph helps us to narrow in on what we're checking, so we don't have to check everything. Okay, let's try this last one. I'll put this guy up here. We have 3x cubed plus x squared minus x plus 1. Now this is a really good one to use with this because notice I cannot solve this by grouping. So this one you have to use the rational root. Well, the number of roots will be 3 because the degree is 3. The factors of p are plus or minus 1. The factors of q are plus or minus 1 and plus or minus 3. That gives me plus or minus 1 and plus or minus 1/3. Again, if we want to, we can check. And for something like this, I'm going to give you access to your calculator because it really doesn't make sense not to. And we're going to clear this, and then we're going to put in 3x cubed plus x squared minus x plus 1. I'm going to hit enter, and because I messed up the window, I'm going to press zoom, and I'm going to come down here to number 6 and say zoom standard. That will put it back to -10 to +10, -10 to +10. Now, I can see it looks like it's crossing at -1. So we'll try -1. I bring the 3 down. I get -3, that's -2, that's 2, that's 1, that's -1, that's 0. Ooh, that worked. Notice how quickly you can do this once you get that pattern down. I now know that I have x minus -1, then I have 3x squared minus 2x plus 1. I could also tell from the graph that there are no more real roots. So the other roots must be imaginary, which also means I need factors of 3 that add to -2. That's not going to happen. So I've got x plus 1, 3x squared minus 2x plus 1 all equals 0. Here I know x is equal to -1. To find the other two x's, I'm going to need to use the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is going to give me 4 plus or minus the square root of 4 minus 12 over 6. 4 plus or minus the square root of negative 8 over 6. 4 plus or minus 2i root 2 over 6. Where did the 2i come from? The square root of negative 8 is equal to the square root of 4 times the square root of negative 1 times the square root of 2. 2i root 2. Okay? Now, when you get to this point, you have to notice that 2 will go into 6 3 times, into 4 twice, and into itself once. Not so quick. So your final answer here, whoopee, all the way down here, let me extend my page, is going to be x will equal 2 plus or minus I square root of 2 all over 3. And then we also have the x equals negative 1 that we found in the very beginning. So we have 1, 2, 3 solutions. Now, fundamental theorem of algebra. The roots of every polynomial equation, even those with imaginary coefficients, are complex numbers. Corollary to the fundamental theorem of algebra states that including imaginary roots and multiple roots, an nth degree polynomial equation has exactly n roots. That's really the only thing you have to remember. If it's a 23rd degree equation, it has 23 roots. That's what you are to get out of the fundamental theorem of algebra. Nobody's going to ask you to regurgitate this. Now, here's some questions that you can be asked that should not take long to answer, and they're pretty straightforward once you understand. For this equation, you want to find the number of complex roots, the possible number of imaginary roots, and the possible number of real roots, as well as the possible rational roots. Notice you're only finding possible, you're not actually solving this. Well, first off, the corollary to the fundamental theorem of algebra tells us that there are 3 complex roots. How? It's a degree of 3, so 3 complex roots. The imaginary root theorem tells us there is either one pair of imaginary roots or no imaginary roots, because you have to remember that imaginary roots come in pairs. They come in pairs. So, since they come in pairs, if I've got 3 roots, only 2 of them can be imaginary with 1 real. So I have 0 or 2 imaginary roots. Since there are 0 or 2 imaginary roots, it follows that there must be 3 or 1 real roots. How did I get 3? Well, I have 3 complex minus 0 imaginary leaves me with 3 real. 3 complex roots minus 2 imaginary leave me with 1 real. So we always identify the total number, then we identify the possible number of imaginary roots because they always come in pairs, and then the real are the ones that are left over. Now, to find the possible rational roots, we find all the factors of p and the factors of q. The possible rational roots, 1 over 1, 2 over 1, 3 over 1, 6 over 1, and you must include the pluses or minuses. That's it. All right, here's one. Pause the video and try filling in the blanks. So you're back. Well, for the equation x to the 4th, notice that this means that we're going to have 4 complex roots. We've got the 4 right here. The imaginary root theorem tells us that imaginary roots come in pairs, so there must be 4 or 2 or 0 imaginary roots. Since there are 4 or 2 or 0 imaginary roots, it follows that there must be 0 or 2 or 4 real roots. 0 plus 4, 2 plus 2, 4 plus 0, all equals 4. Now, remember that we have Q tip. Factors of P, plus or minus 1, plus or minus 3. The factors of Q happens to be 1, so that's plus or minus 1. The possible rational roots, 1 over 1 is plus or minus 1. 3 over 1, plus or minus 3. And that's it. Here's one more. Try this one. Pause the video. Okay, you're back. 3 complex roots, meaning that there are 2 or 0 imaginary. Since there are 2 or 0 imaginary, there must be 1 or 3 real roots. My factors of P, and again, remember Q, tip, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Q happens to be 1, which is ever so helpful. Plus or minus 1, which means the possible rational roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. If you ever have, like if Q was 2, then you wouldn't repeat any of the possible rational roots. You only list the ones that you know about. Okay, so in other words, let's just say that, let's pretend like this was a 2. Then in that case, you'd have plus or minus 2. So when you went through all of this, you would have 1 over 1 is plus or minus 1. Then you'd have 2 over 1 is plus or minus 2, plus or minus 4, plus or minus 8. Then you do 2 over 2, but you already have 1, so you don't do that one. Well, you do 1 over 2, so you get plus or minus 1/2. 2 over 2 is 2, so you don't need that. 4 over 2 is 2, you don't need that. And 8 over 2 is 4, you already have that. So this would be your possible rational roots. Don't double list things. Okay? Now, more theorems. And these we're not really going to do a whole lot with, but the irrational root theorem. That says let A and B be rational numbers, let the square root of B be irrational. If A plus the square root of B is a root of a polynomial with coefficients, then the conjugate is also a root. So this also tells you irrational roots. Okay, irrational roots come in pairs. Think about plus or minus the square root of b squared minus 4ac. Okay, this is where you get your 2, your pair, and it's the conjugate. Okay, plus and minus. A polynomial equation with an integer coefficients of 1 plus root 3 and negative 11. What are 2 additional roots? Conjugate would be 1 minus root 3, and the conjugate of, think of this as 0 minus 11, is 0 plus 11, or just positive 11. Okay? Now, you try one. Did you get 2 plus root 7 and negative root 5 as the 2 additional roots? Great. So remember, if somebody gives you an irrational root, one irrational root, you actually know the other one. Just have to do the conjugate. Similar thing, the imaginary root theorem, which also comes in pairs. It's conjugates. Again, plus or minus the square root when what's underneath when the discriminant is negative, you're going to have imaginary. So if we had 3 minus I and 2I, you would have 3 plus I and negative 2I as your additional roots. Try this last problem down here. Did you get negative 3I and then negative 2 minus I? Remember, this is the sign that you're changing. Those are the conjugates. Now, we're going to look at using the rational root theorem one more time. Given the function 5x cubed minus 11x squared plus 7x minus 1 equals 0, find the leading coefficient. Find the factors of the lead coefficient. Identify the constant and give me the factors of the constant. Now, pause the video and do that. Did you get 5? Did you get plus or minus 1, plus or minus 5? For the constant, did you recognize that as negative 1? And then the value of the constant is just, I don't know why this little guy is here. He should just be up here. Plus or minus 1. Now, if I want to find all the possible rational roots for the function above, then any actual rational roots, and I'll explain the method. First off, there's nothing I can do as far as grouping. So possible rational roots, plus or minus 1 and plus or minus 1/5. How did I do that? Well, over here, this was all my p's over all my q's. That's where these all came from. Actual. Well, now the actual one I'm going to show is 1/5 or 1. If you graphed this, you would find that it's crossing at 1/5 and at 1. Okay, so if I wanted to, the method I could do is 5, -11, 7, -1, and I'm going to put 1 up here. The 5 comes down, I get 5, I get -6. That's -6, that's 1, that's 1, that's 0. So that would tell me that I have x minus 1, and then 5, x squared minus 6x plus 1, plus 1. Yeah, plus 1. The whole thing equals 0. Okay? And then, if you wanted to, you could try the 1/5. Okay, and you would find that the 1/5 also works. Now, can you keep factoring that? Sure. But that's not where we're going yet. Now, what if you're given this function? X cubed minus 5x squared plus 2x is plus 8. Identify all the possible rational roots. Go ahead and do that. Oops. We'll make this guy fly away. Properties, object animation. We're going to tell him to fly out. Ooh, he went backwards. Let's go top right. There he goes. Okay. Now, go away. Here are all of our possible rational roots. Remember, you had q, tip. Now, identify one actual rational root. Use synthetic division to begin factoring. Because even if I use my calculator, that only gives me 1. That doesn't give me the rest of it. So, oops. On y equals clear, we'll have x cubed, cubed, minus 5x squared plus 2x plus 8. Oh, and see, that's where I'm going to come back up here and clear this. We have x cubed, and in class somebody would have been yelling at me, minus 5x squared plus 2x plus 8. Now I can graph this. And it looks like at -1 and at 2 and at 4. So I'm going to try -1. Okay? So I'm going to come over here and I'm going to say -1. So the 1 comes down, -1. I've got -6, that's 6. This is 8, that's -8. Yay. So now I've got x minus -1. I have to find the other factor. Well, x squared minus 6x plus 8 all equals 0. This is a plus. So x plus 1 is equal to 0. x squared minus 6x plus 8 is equal to 0. X equals -1 here. This I still have to factor. X minus 4, x minus 2 is equal to 0, which tells me that x is equal to 4 or x is equal to 2. So here I found x equals -1, x equals 4, x equals 2. I identified one rational root, -1, and here I used the calculator. Okay? Now, given the function x cubed minus 18x plus 27, find all the roots of the polynomial. Go ahead and try this. Did you get 3 and then -3 plus or minus 3 root 5 all over 2? Okay. Well, first off, I need my p's and my q's. My p, plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. Q is 1, so I don't have to do all that. Now, I would graph it, and after graphing it, you would notice that it's crossing at 3, or it looks like it's crossing at 3. So you would have 1, 0, -18, and 27. Ooh! Where did the 0 come from? There is no x squared, so I have to account for it in my synthetic division. Now I bring down the 1, and I get 3. I get 3 times 1 is 3, and then I get 3. If you forget this 0, your answer is going to be wrong. 3 times 3 is 9. -18 plus 9 is -9. 3 times -9 is -27, and I have 0. This gives me x squared plus 3x minus 9. There are no factors of -9 that add to 3. So therefore, x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, and now we already know that x equals 3. That one checked. So here x is equal to -3 plus or minus the square root. This is 9 plus 36. Negative and a negative makes that a plus, all over 2. X is equal to -3 plus or minus the square root of 45 over 2. If you left it like this, you would miss like a point because you need it in simplest radical form. Remember that this is the square root of 9 times 5. So x is equal to -3 plus or minus 3 root 5 all over 2. Okay? On your test, if you saw simplest radical form next to this answer, I'm asking you to finish it up here. That's a wrap. You've got your summary, which just goes through the rational root theorem, the fundamental theorem of algebra, the irrational root theorem, the imaginary root theorem. Combining all these together allow us to figure some things out about a polynomial. This takes practice.